Okay, now we have seen the hardware part, now the software part. So, uh, what is the software? Well, everything in the computer is controlled by these softwares, and we can basically convert them to system software or the application software. So what is an application software? Well, we use this software to do our daily tasks like Microsoft Word. So you write your document, you prepare your presentation, and so on. Or a movie player, so you watch some videos and so. The web browser, it helps us to visit the web pages and so on. So these are the application softwares or the games and so on. What about the system software? These softwares actually helps us to control and manage our computer. For instance, the operating systems like Windows, Linux, Mac. What are these? These are operating systems. Actually, what is that? Well, as a user, it's so hard for me to know all the technical details of a computer. Like it has RAM, it has hard disk, it has CPU, and it's so technical than hard. And how can I move a data in a hard disk? Like I don't know where to put it. Like I have 1 TB of hard disk. Okay, I have one image file. Should I keep it there? Should I keep it there? How can I do it? It's so hard for me to do that. Like because it is a hardware, but I'm just a user. Then I need a software actually that will handle all these technically hard, sophisticated applications on the hardware part, but just will provide me a user interface so that I can easily copy file like, okay, just drag that image from here and put it there. So it will do all the operations in the hardware. So the operating system is actually allows us to control the hardware components and without dealing any details or most of the details about those components. Or the utility program like well, maybe I need a cybersecurity antivirus program because someone might attack and so on and so, or I might need to remove some, I don't know, unnecessary files and so on. So I need those programs not to do my daily task, but to enhance the performance of my computer, to improve that. So this is the utility programs, and also the software development tools. So eventually I might want to develop my own software, maybe an application software. Maybe I will just change the operating system a bit. If you are a Linux user, you can literally do that. So I need also a tool that will help me to write a software. So the software development tools can be considered as a system software. I think I already provided examples, so I'm just moving on. Now, how a program works. In modern computers, the process is so complicated, but in a simplified version, and in generally, we can say that we have these 3 steps: fetch, decode, and execute. So what are they? Now, firstly, we keep everything in our RAM when we are using the computer. The programs, the software, the data, everything. And the RAM keeps the data in bits, in zeros and ones. So actually what is happening is everything is actually translated into these zeros and ones so that the computer can run it. So the CPU first fetches the next instruction to be executed. But then it decodes the instruction. So what does this mean? 0, 1, 1, 1, 0, 1, 1. What it should be done? Is it an addition? Is it a multiplication operation? What is that? So it decodes it, and then it executes the operation. So fetch, decode, and execute. We have these 3 main cycle. And then once it executes, it goes back to the fetch operation and fetches the next instruction to be decoded and executed. Now, what is a programming language then? Now, okay, we talk the softwares, okay, this is how it works, but then, okay, how can I define those instructions? We define it by programming languages. Like, I'm using English to communicate with you, then I also need a language to communicate with the computer. And that language is called programming language. So we use it to write the programs, to write the instructions so that the computer can run it. We can divide these languages also into two parts, like low-level languages and high-level languages. Now, here is the main challenge. Computer understands only what with zeros and ones. For me, it's not readable, understandable language, like 0, 1, 1, 1, 0, 1, 1. Okay, what did you mean? I have no idea. I have to decode it and so on. But eventually, I also need to design programs. I want to reduce that technical complexity. Like, okay, theoretically, yes, I can map what those zeros and ones mean, and then I can translate it or maybe use it, but practically it's extremely hard. So I need those kind of languages. The first one is a low-level language, which means it is close to that machine language, which means that the language that the computer uses with those ones and zeros. But we'll see an example. It contains so many, again, technical details about the computer. That's why we call it low-level language. What does it mean? For instance, here you see an example. Int count, move total 48, add AH and BH. So when you see that, okay, it's now it is it makes much more sense compared to these zeros and ones, because I can at least understand inc, okay, it means increment, count, okay, increment the count value, or move, MOV, move, okay, it stands for move, total 48, so move the value of 48 to the total, okay, I can still understand it, at least, and mask 128, so do an AND, logical AND operation with these two values, okay. Now, compared to zeros and ones, it's way better, because now at least I can understand what I'm trying to say. But of course, this is for me to write it. Like a person can write this code, and then we still need to convert to zeros, ones, but it is at least still easy for me. If you are doing a low-level language, like how the CPU should work and so on and so, yeah, you might need to write an assembly code. But it is still so hard for me because the instruction set is actually pretty limited, like addition, AND operation, I don't know, division, and so on and so. But eventually what I want to build is, let's say, ChatGPT. Well, the thing is, okay, how can I build a ChatGPT by using addition and moving logical ends and so on? Well, theoretically you can, but it is so hard. Like because there's so many things you have to write to reach that level, but using with these low-level operations, it is so hard. So we need another programming language, high-level programming language, which basically hides almost all technical details of the CPU, of the RAM, and so on, so that it allows me to imagine. It allows me to design the bigger things so that I can implement all these other fancy softwares. So these are called high-level languages. They are very close to, in some sense, once you get used to its language, you might find it close to, especially English. For instance, because it contains many even simple English words. For instance, you see a statement here. Basically, if it means, I mean, I can almost translate one word by word. Like, if A is equal to B, then set X to 0. Else, otherwise, set X to 1. So now, this is, compared to this assembly language, it's much easier to understand. And a single statement can accomplish many tasks. I could also write this with the assembly language, but I would use a higher number of instructions to express the same thing. So it actually helps me to write programs in a much easier way. Um, and Python that you will see in this lecture is also a high-level programming language. So it actually hides many details. You don't need to worry about, okay, where your data is located in the memory. You don't know. We don't need to know about it. Or which, okay, in order to do this statement, did you do adding, multiplication, logical and so on and so? You don't need to deal with that also. It will hide all these kind of technical details so that we can think about the bigger issues, the design issues. But now, the other part is now, let's say, okay, I write this, if A is equal to B, then X is 0, then otherwise X is 1. But the thing is, how can a computer runs it? Because the thing is, I said that the computer cannot understand zeros and ones. Okay, now there's a language barrier. It understands zeros and ones, but I'm writing in Python or Java and so on. Now, we need a translator, which will take my language, my code in Python, translate it into the machine language. So basically, I will run, and this part is called compiler. So I will write my code like this, so that I can, it's easier for me to understand what I'm trying to do, but then the compiler will convert it to this, to zeros and ones, so that the computer will understand what I'm trying to say. So the compiler is our translator that we use to communicate with the computer. And the way this compilation works actually differs from programming languages. In languages like Java or C, C++, what you do is you first write all your code. Let's say that you want to build ChatGPT and you need to write, I don't know, 1 million lines of code. You first write it and then compile it and then you can run it. So you have to finish all your program and then compile it and then you can run it. But the other language group, which Python is in, that it is called interpreter. They use an interpreter. What does it mean? You need a 1 million lines of code for your program. Okay, but what it can do is it can first take the first statement. The interpreter converts it to machine language, and the CPU runs it, and then the interpreter fetches the next statement and converts it to machine language, and then the cycle goes in this way. So which means that you can, even though you finish only half of your program, okay, you need 1 million lines of code, but you just have written only 500 lines of code, you can still run those 500 lines of code by using the interpreter. So you can still run that a portion of your program in an interpreter, and in Python you can do that. In Java or so, no, you cannot do it. It forces you to finish the program to be able to run it. Now, we have these, I think, now these questions are for you. I would like you to answer that. This is also important that you might see this type of questions in the quiz and midterm. So when a program runs on a computer, the part of the computer that carries out the instructions is called, what is it? RAM is to keep the memory, but it says it carries out the instructions, to run the instructions. Software is the set of the instructions. We are asking actually a component, a hardware component of the computer. CPU, yes. The central processing unit is the one that carries out the instructions, that runs the instructions. And a bit is a binary digit, like 0 or 1. And a compiler, what is it? It maintains a collection of programs, tests a program's logic, translates source code into executable code. Translation. Yes. So I also would like you to attention that please get used to this kind of question. So yeah, in the quiz, and so we might ask this kind of fill in the blanks type questions. And it is important to know these concepts because we will not come back to say that, okay, what is a compiler or interpreter. I will just say that compile your code or do so that I'm expecting that you will understand what I mean by these kind of terms. So what is a program is made of? I have 8 minutes. Okay. Basically, statements. A program is basically a set of instructions that we tell the computer to do. And it has its own, let's say, grammar rules, okay? Like in language you have, I don't know, adjectives or punctuations and so on and so. So you have some specific words that have some specific meanings. In these languages also we have keyword and we have some in a sentence structure, like you might need a noun, verb, and so on and so in English. In a Python or these languages we need keywords, operators, variables or punctuation and so on. Now we will see these in a very briefly. First, the keywords, or we can say that reserved words. So what does it mean? These words have a very specific meaning in coding. So we cannot use them for any other purposes. What does it mean? Well, we will see it in the following slides actually. When we are writing program, we actually give many names to many things. Okay, so we are actually kind of a free in terms of giving names that I will talk about later on. But we cannot use these words, okay? These are specific words. What are they? Well, break, continue, if, for, while, or for Python we can say def, and so on and so. These have some specific meanings that helps us to write our instructions, so we cannot use them to give a name to other things. And the other one is programmer defined identifiers. What does it mean? Well, okay, now let me explain it in this way. So we use computers to do some operations. I can also do it for them manually. Now, what I can do is, let's say that I want to find how much price I should pay when I go to the grocery, okay? So what I usually do, I mean, if I didn't have any computer, or if the machine that I paid him, if it didn't calculate it, we would do it manually. So what I can write is, I need a paper. Paper is my RAM actually, the part that I'm using to store my data. And then on that paper I will write, okay, I wrote bananas, and the quantity of it is 2, and its price is, I don't know, 5, so the total will be 10. Then I write, okay, I also put tomato, the quantity is 3, and I don't know, price is 5, and the total is 15. Then I need to sum it up, it makes 25, and so on. So I will do this operation. When I'm doing it, I'm actually writing many things and giving a name actually, like, okay, quantity of banana, quantity of tomato, the price of a banana. So I'm writing these, or the item name, the banana. I'm writing all these things. I'm giving names actually. So I also, now I want to tell it to the computer actually. But of course, I'm actually more free here. That's why we are saying programmer defined. I don't need to say banana actually. I mean, it will be good to the computer if I can say, okay, I just bought X, okay? That's called X. I gave it a name, X. And then for the total price, I am writing it. I said, okay, it's, give it, I don't know, total price of banana. So I'm giving names actually. Why do I doing it? Why am I doing it? The reason is that, actually, I'll show it here. Not to deal with the technical details of my RAM. Like in your paper, for instance, if you are using all these numbers, you should know that, okay, where should I write the banana here? Okay, where should I write this quantity here? So I know the location and I can see that, but I should always remember that, okay, this number 2 represents the quantity of the banana, and so on and so. But how can I deal with a memory that I don't even see? It's not a paper that I can see. and it is a very technical part, and it's actually a very large paper. You might think it in this way because it's, let's say it is 32 gigabytes of RAM. So which means 32 billions of zeros and ones. So it's a huge one. And when I'm doing a calculation, if I said, okay, this is the tomato, I put it here, then later on once I will use it, how can I find it? Like, okay, where did I put it in the RAM? Okay, so huge, and there are so many other data. Which one was it? So that would be a big problem. Like I either have to memorize the address locations. Okay, then it increases the complexity a lot because then I said, okay, memory location 75 keeps the tomato. Memory 77 keeps the data for the quantity of the banana and so on and so. But it is so hard. How can I, because 75, 77, how can I memorize it? I'm trying to reduce the complexity of programming, okay? Because I don't want to be drawn in these technical details because I want to build a ChatGPT or so. I want to build a bigger thing. And I want to use my mind power, intellectual power, not on these technical details, on the larger problems. That's why what I'm doing is, instead of memorizing all these numbers, what I'll say is, okay, num1. I said that, okay, num1 should be 5. And then num2 should be 12 and sum should be 70. And then in my program, whenever I need num1 again, I don't need to say, okay, give me the value in the location address 71. I'll just say, give me num1, give me num2, and then it's the computer's work to find that data, which is named num1, and then give me that, okay, this is num1. Like you can think it from my banana example. I will say quantity of banana. This is the name that I give, and then I keep it here. Then I will not deal with all these memory location details. I will just say, okay, the quantity of banana, give me that, and then it will find it in the memory and give it to me. That's why, now I'm going back to this slide again. We define many names, identifiers. We use these so that not to deal with these details. And the other part is, okay, I have 1 minute. Operators. So yeah, we also define operators like the addition or the logic multiplication or the logical operators in our statements. The variables, as I said, it's a named location in the memory. And all this makes the instructions. Now, I think I need to stop here because it's 10:49. Let's stop here. We will talk about the algorithm in the next lecture. Thank you for your attendance. This is the class for today.